Hello viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about motor generator unit, the worst name in history. So let's dive right into it. Now, the reason why I classified it as worst name in history because the first time you search motor generator unit, you'll get a lot of free energy BS. But there is no technical name for it, meaning a motor that is behaving like a generator and motor interchangeably does not have a name to it. And if you type motor generator unit, unless you put F1 or kinetic energy recovery system, you will not get anything. So it has a really bad name because you will generally see something that converts frequency, basically a DC motor that is connected to an AC generator, that is motor generator unit. However, this puppy is one rotational mass, meaning the thing that is rotating is doing both of the work, meaning creating energy and consuming energy. So that is very critical. Now you may be like, does that mean you have to create something new? No, fundamentally speaking, as in go to the core level, motor and generator are exactly the same, meaning how many things are present in a motor. If you remove everything, go to the physics level, what do you have? You have magnetic line, you have basically energy, basically magnetic line, electrical energy and motion. Now you have two options: you dump energy into it and create motion, or you can extract energy by utilizing motion. Basically you input motion, get energy out of it, or you do the reverse. So inherently motor and generator. Now it works with every single type because there are hundreds of types, and you may think, oh no, this may be true to something, this or that. No, it's true to everything. DC basically DC motors which are used for locomotives and all that jazz, they work. Induction motor, the most common motor ever created, they also can act as a generator. All you have to do is spin them fast. Generally it's said, like some people say, at as low as like 50-60 hertz you will start to get that. Or if you want to be damn sure that it produces energy, spin it at positive slip, meaning if its RPM supposed to be 1500, spin it at 1600, it will start to act as a generator. However, you will need a run capacitor to keep the self excitement going. And yes, there are companies that make this sort of basically induction motor as a generator. Even if some wind turbines also use that. So yes, normal induction motor, you do not have to make any modification. Everything outside of it as a basically drive circuit, meaning all you have to do is have some capacitors. Done, go home, sweet dreams. So even this puppy, BLDC, it has magnets, so most people can inherently think about it. It's like you have magnet, you have motion, you get energy out of coils. So that does work. Universal motor, it does not have a magnet, still will work, but it does have brushes. That are some consequences. And some design does require excitement. For example, induction motor, universal motor, and even DC brushed motor, they will work as a good generator, but they will need a bit of initial boost. So if they are working as a motor in the start, then they will work as an amazing generator, but you cannot directly expect it to spin and create as a generator. It will need a bit of initial juice, so to say. So other than that, most of the things will work motor and generator without any issue. It's only up to the controller, can it do that or not. Now electrical energy to rotational energy or vice versa, it's fundamentally the same. It's right hand or left hand, inherently they are the same thing. So same thing, as in like what you put in, what you get out, that's the only thing that are changing. You are either inputting energy, you're getting motion, or you are extracting motion, getting energy out of it, meaning you are spinning it using a generator unit, basically internal combustion engine, then yeah, you are getting electrical energy out of it. Motion, magnetic field is the same in both of them. So be very mindful. Do not ever think about, oh, motor or generator. No, they are same thing. Both, all designs, everything ever made. Now, what are the uses of something this convoluted, this complicated in terms of driving circuit? Well, reality is, most of you have heard of it, specifically regenerative braking. Every time people are like, regenerative, what is that? It's like when you are going at, let's say, 100 kmph and you want to apply brakes. In an electric car, the brakes will not engage if you press it lightly. All it will do is trigger a system. On basically induction motor is like, hey, will you start acting like a generator? And then it will sap the energy. Basically it will take a rotational energy that is in the wheels and directly turn this puppy. Now consequence energy cannot be created or destroyed. It inherently end up, the more energy is coming out of this puppy is the more energy that is being sapped from the motion of the car. So car will slow down. And the benefit of this thing is like brakes, they have a very non-linear response. So meaning if you want to slow down a vehicle from 50 kmph to 0, your brake pads is like, dude, I don't even care. It's like, I don't care, I don't even heat up at this. Now if you try to do that 100 kmph to 50 kmph, it will like, dude, this is too brutal. It goes linear, ludicrously exponentially. So but this puppy works opposite way. So it cannot stop your car. No matter what you do, it will not stop it, but it will slow it down. So if you're traveling at 100 kmph and if all you want to do is bring it down to 50 kmph, this is like, I'm your friend. And benefit of this, your brake pads on electric vehicles wears out less because on slow speeds, brake pads, know how to make brake pads that will last inherently forever at slow speeds, but at high speeds, that's where they are at fault. And regenerative braking is like, high speed, I got this. So regenerative braking. And then we have integrated starter generator for internal combustion engine. Now be mindful, this is kind of a new technology. Indians have access to it in basically two-wheelers. Most of the Asian markets have two-wheelers that have integrated starter and generator. So if you are familiar with your cars, you know alternator is a thing, starter is a thing. But here's the deal, why do you have two things? All of them do is the same thing. It's like you have magnetic field, you have motion, and you have electrical energy. Why can't you just interchange it? Somebody figured it out. So now it's a very common thing on motorbikes in India that are new and specifically built, and even on luxury cars they are becoming a new thing, like Mercedes 48-volt system, where you have integrated starter and generator unit, meaning you do not have two things, you have one big thing. Then oldest use of this sort of system is train dynamic braking system. People do think of the idea of like regenerative braking is a new thing, it's coming with an electric vehicle. No, it's like it's the same thing. Resistor braking has been used with every locomotive since very early, as in like 1950s and all that jazz. So idea was very simple. DC motor, while it's behaving as a motor, while your train is in motion, if you try to convert it into a generator, it will work amazingly well. Now why would you want to do that? Same thing, if your train is like traveling at like let's say 50 kmph, you want to drop it down to 25 kmph, your brake pad will wear very quickly, like brake shoes, those things, they will wear very quickly. However, if you want to drop them from 25 to 0, brake pads, brake shoes are like, I got this. So same thing is done. So basically inherently converting the inertia into heat energy and doing it through the motors, you do not have wear and tear on the things that do have wear and tear. There is no wear and tear utilizing this resistor braking. And they generally have a fan that is also coupled with that output. So meaning the higher the output, the faster the fan will spin and higher this heat will happen. So there is an inherent limitation and failsafe built into this. So these puppy can dump megawatts of energy basically. So they can have like a long freight train, and if it's going down slope, I'm saying basically down slope, they will just turn on the dynamic braking. So it will never speed up because it's always burning off the energy. So dynamic braking is always used, and this is the reason why we have very good long hauls of trains. Without it, brake shoes will wear too quickly. So dynamic braking, it's very old use. Then we have large scale energy storage. For example, pumped hydro. In many pumped hydro systems, you have one unit that is doing the pumping and turbine, basically generator unit. Basically you are pumping water up and then you are letting the water run the turbine, and then it acting as a generator, both in the same unit. Benefit, much cheaper cost. And you are talking about equipments that are in multi-megawatt range, having multi-megawatt generator, multi-megawatt motor. Yeah, they will be ludicrously expensive. If you have both of them in one, all you have to do change is having a different kind of electrical system. Basically driver electronics will change, other than no other change. Is super cheap. You have one unit, you have to dig one tunnel from like high reservoir to low reservoir. Everything is simplified. So a lot of people develop very huge systems for this. I'm talking 50-60 megawatts or even higher than that. And then F1 recently introduced what we call thermal energy recovery system. Many people they know kinetic energy system. What the hell is thermal? Well, thermal is if exhaust gases, when you floor it, basically F1 system, let's say you floor it, you went YOLO on the accelerator, your engine will start to produce RPM. That RPM will start to create boatload of hot exhaust gas. Now hot exhaust gas will generally go from turbocharger. Now it will supposed to give you boost, but there is something known as inertia. So if this spinning thing is spinning at let's say 10,000 RPM, it will not instantaneously go to 20,000. It will take some time. And again, it will zap a lot of energy out of it. Now if you are in F1, you want, like, I press the accelerator, I want to go. So what will this unit do is act as a motor and spool up much more quickly. So exhaust will take let's say 2 seconds to spool up. This is like, I got this, half second spool up, done. So basically you press the accelerator, your car is like, I got this. Now that's awesome, but here's the, you took the overtook, now there is a turn, now you have to slow down, otherwise you will crash. So this puppy will act as a generator, meaning that will start to sap energy away from the exhaust gases. Benefit of this will be you are basically collecting thermal energy, because that exhaust has two components, not gas volume and temperature. Both of them are helping you to spin the turbine. So that's why it's called thermal energy recovery system. So turbo boost is done. Now this is not limited to F1. F1 is something that popularized it, but now this sort of system is used in marine industrial diesel power plants, meaning huge container ships. They need a lot of auxiliary energy units. So basically they will have 50 megawatt unit that is producing the power and driving the main ship, but you will have something else to provide electrical power for everything else. Somebody came up with the idea, it's like, dude, you have huge ass diesel generator which has huge exhaust pressure, why don't you utilize that exhaust pressure? And this also has the benefit, you can start the system, it's pulling up time, big unit, you can use it as a motor and it will start up very quickly, and then once it's done, once the engine RPM is reached to to the stable unit, it still has way too much exhaust pressure. You're like, okay, run as generator, everything is optimum, you're getting energy from exhaust, so everybody is happy with this. So that's the primary use I have seen, where it's like, no, it's really helpful, like as in it helps people save millions of dollars per trip. So that's the use of this. So there are option. There are two major options. One is magnetless, another is magnet one. So DC motors are very easy on this. Like DC magnet, if you buy a DC motor, and if you short it out, basically it's spinning. You have a flywheel, it's spinning, and you want to stop the flywheel, just short it out. Now again, generally only do that with small motors, because if you do that with big motor, the coils will burn up. It has too much energy as a generator. So that's why in basically locomotive, when they are doing it with multi-ton objects, they generally have a braking resistors where they can dump that energy. So DC motor does that. However, consequence of that, it utilizes brushes. So DC motor systems have been phased out. People don't like brushes. It requires way too much maintenance. It's a fire hazard, and it's really not a good thing. So DC motors generally can deal with that with brushes. Induction motor, lovely thing, every electric vehicle uses that, but it does require complex VFD, because I have specified to make induction motor into a generator, you have to spin it faster than its rated speed. Meaning, if let's say it was a 50 Hertz system and it's supposed to rotate at, let's say, 3000 RPM, you have to rotate it at 3100 RPM. Now you may be like, hey dude, I'm applying brake, how the heck it will go in higher RPM? Well, it won't. That's the problem. Then how the heck you will make it into a regenerative system? VFD to the rescue, variable frequency drive. Now if you are familiar with what we call grid tie inverter, think of it that way. So once you start to reduce the frequency, the rotor basically will think, hey, I'm spinning below what we call slipstream. Basically I'm in positive slip. It will start dumping energy into the frequency, like how a grid tie system does. So this way you can basically allow this RPM to go down very drastically. So for Tesla motor, the highest RPM is 20,000 RPM, and I'm pretty sure it will allow you to do energy recovery as low as like 5,000 RPM. Now be mindful, it is an induction system, it is utilizing VFD, so it's not as efficient if it had a permanent magnet into it or some sort of other electromagnet at its rotor part, but it does work. And you are removing the energy that you put into acceleration. Now generally people are expecting around 30% efficiency. So let's say you put 1 kilowatt of energy into accelerating your car, you're supposed to get around 0.3 kilowatts when you are doing braking. So that 0.3 kilowatt is saving your brake pads. That's why your brake does not wear. That amount of energy is no longer dissipated by your brake pads. The brake pads is like, I got this. And at lower speed, brake pads are far more efficient. So this will slow it down. Never expect this sort of technology to stop your system. It's only there for, let's say you're traveling at 200 kmph and you like apply the brake. From first 200 kmph to let's say 50 kmph, this will like, I got this. After 50 kmph, it's like, bro, I'm at useless speed. Please apply disc brakes now. So that's how VFD system works. Now, benefit of magnetless system is they are generally built for huge loads, meaning even in car, I'm talking about 100 horsepower or even 200 kilowatts, 300 kilowatts, or in case of trains, they can go up to 1000 kilowatt, almost 1 megawatt. And in terms of basically, when you're talking about turbine systems, which are used for pumped hydro, megawatts. So there are the benefits of magnetless system. If you want to scale it up, this is like, I got this, fam. So that's the magnetless system on this. Now what about magnet-based system? Now BLDC, if you know BLDC system, that's all we are talking about. Now neodymium magnet, because there has been a recent trend in neodymium magnets. Earlier the interest on neodymium magnets was with headphones, and basically Sony kind of popularized it with headphones, and computer industry loved it for hard drives. So neodymium went from only few hundred tons production to few billion ton production recently. So inherently boatload of company is putting boatload of money to make this sort of magnet system. BLDC is rather simple to make. Now it's super easy to drive. You do not have to have a complex circuitry. As a motor or generator, it's like surprisingly simple. Specifically as a generator, you don't even have to have exciter, capacitors. It's like just spin it, done. That's why people like magnet system. Just spin it, done, go home, sweet dreams. But they do not have any control output. If you have watched my previous video of car alternator, I specified car alternators have electromagnet at its rotating part. It's called field strength, and it's supposed to be controlled. The reason for that is your engine RPM has ludicrously high range. It's not a generator unit. Your car engine could be idling at let's say 1500, and when you floor it, it could go as high as 8000 or sometimes even 10,000. In those sort of scenario, your alternator, if it had a permanent magnet, voltage will go literally from, oh, I'm producing 12 volts at idling, 15 at mid RPM, and the moment you start to floor it, it will like, yeah, I'm putting 50 volts into your battery and cook it. So there is no control if you do not have electromagnets. That's the problem with BLDC. If you are using it as a generator and it's directly connected to your, let's say, engine shaft, or let's say in a two-wheeler system, the RPM range creates an issue where it will create whatever it wants to create. Or of course there will be a power graph, you can look at it. It's like, hey, at this RPM I'm producing this, at this RPM I'm producing that. So that does mean the inverter unit that you are putting, the controller circuit, that has to be much more robustly built so it can handle much higher voltage. So even the output voltage would be locked at, let's say, 13 volts. The input voltage could easily go from, let's say, as low as 10 volts to as high as like 100 volts. Now they are very popular because of simple bit. Everything is simple about this. Like you can just call up people and he's like, hey, can you give me this BLDC motor with this kind of current? They're like, I got you, fam. However, the inverter unit is the expensive part, and not only that, it's acting as a, like, charging unit. It also has to run as a motor unit, electronic speed control unit. So that is a bit expensive. So that's why it was not done before. Like the motor was not a expensive part. The motor and generator unit is the easy part. The hard part is the brains that drive this sort of system. But I've never seen this sort of system go up to ludicrously high power ranges. The magnetless system, they do go to very high power ranges. This do not. Now let's talk about something that most people are familiar with, this puppy in India, that is ACG Starter. Now I have no idea who the hell came up with that name. That simply translates to alternating current generator. I'm like, every generator is alternating current generator. Like there is no such thing as DC generator. Even if you take a DC dynamo, look at the output in an oscilloscope, you will know it's always doing that because it has split rings or commutators. So it's like literally instead of letting it go down, it's like, no, I'm disconnecting you. It's like basically you have a mechanical inverter in it. If you are using motion, you will always create alternating system. So I do not get this. Just call it like, motor generator unit. That's why I specified the name of this puppy is really hard to Google search for. So that's the whole point, the BLDC motor. Now the benefit of that, it improves mileage. You're like, how the heck it will improve mileage? Well, before this we had two systems. You had a generator, you had a starter motor. Now throw both of them away, just have one big thing in there. Awesome. Now BLDC acts as a starter motor. Benefit of BLDC is because it's utilizing magnets rather than electromagnets, it does not have huge amp inrush. Meaning, if you're familiar with electric starters, they have very big power draw. They like chunkus amount of energy they take to start the system. And because of the improved engineering, we learned the fact that your engine needs to have a flywheel. Somebody figured out, hey, BLDC has a rotor, you need something known as flywheel. You need basically rotating mass. Just use the rotor as the flywheel, and that's why it can even basically reduce the footprint of the system. Your combined basically mass of the engine goes down. That's why they said like it improves efficiency, because dead weight on your vehicle goes down while you are getting higher functionality. It does create AC, you have to be very mindful, and does have that issue of like ludicrously high voltage range. So if at let's say at idling RPMs of let's say 2500 is like awesome, but then moment you floor it, it will go very high, and the inverter unit has to be basically, this brains has to be smart enough where it's like, whoa, voltage is going too high, either dump the energy somewhere or just disconnect it. Like not relay disconnected, as in float it in IGBT. So rotor does act as flywheel. It makes it smaller and compact, and it does have a much lower drain on the battery when you're starting it. If you're familiar with starter system, they have a huge interest. Like you can only crank for a few times, 1 or 2 times. Now these puppy, basically the system, even my dad's scooty has this. It can like literally, if you are stopped on a stop sign, you can just stop. You don't have to think about it. It's just like stop, your engine will automatically shut down, and the moment you floor it, it picks up on. Why? Because this system can, if you have the same amount of energy, let's say 100 kilowatts of energy, 100 kilowatt is too high, let's say 100 watt hour, this puppy can crank multiple times on that, versus a basically normal starter motor, it will crank only few times, and it has like that huge inrush, basically destroy your battery. So that's the benefit of this. That's why people are pouring money into this, because using the same components, basically 12-volt battery, you'll get far more energy out of it, you'll get far more usable life out of it. So everybody wins, except the inverter system, because this puppy is the one that's suffering because of all this amazingness. It also acts as a silent start. That's how Honda sells it. It's like silent start with ACG. Everything is awesome, but that inverter unit is the expensive part. Nothing is there that will wear down. The magnets will take very long time to demagnetize, and coils are rather simple. So there is nothing inherently expensive until you talk about the brains of the system. And there are some serious advantages. The benefit is like, I love the fact that on even small stop signals, basically where you are like, oh, I'm only stopping here for 15 seconds, you can turn your engine off, and this will reliably start it on without you ever worrying about it. And if you're stopped for 2 minutes, you can do that. If you do that with your normal starter system, there is a very good chance you will not have cranky unit. You have to physically kick it. So That's why people are pouring a lot of money into this. Now be mindful, this is a two-wheeler system. There is a four-wheeler system also available, but they are right now very expensive, only available for luxury kind of car or Mercedes. So that's the ACG starter system. So this was my presentation on motor generator ideology. I hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.